D is the distance between the slits, so each one of those slits, small, and it's generally really small, okay? Theta is the angle from the center of the slits to the bright fringe. N is the order number of the bright fringe. X is the distance from the central fringe to another. Oh, and let's write some of these down on our thing, too. So here, sorry, I forgot about that. So here, if we look at these angles coming out, this would be like our thetas, okay? Theta 1, theta 2, okay? So it's just how the angle goes out to the first bright spot. Now, the X, it says it's the distance from the central fringe to another. So this distance, here to here, that would be like an X. This is X. N is on the bright. I think that my picture might have shifted. I feel like, yeah, it did. I can just erase it. The N should be on the bright. Yeah, I think my picture shifted a little bit there. So N equals 0, N equals 1, N equals 1. So here's your thetas. And here would be your X. Yeah. Good. Okay. Now, and then L is the length from the screen to the, where the slit is. Okay, so the equation lambda equals d sine theta over n can only be used, or can be used for any diffraction question. There's no parameters about when you use it. But this one can only be used when theta is less than 10 degrees, okay? Must be. So to calculate the angle between the central maxima and the maxima being studied, simply use trig. Both equations can be used to compare how one variable is manipulated and how another variable will change. So, for example, if lambda equals xd over nl, say we rearrange to compare lambda and x, well actually we don't have to rearrange it at all. We see here that lambda is proportional to x, so therefore, as wavelength lambda increases, the distance between the bright bands increases. So depending on kind of what wavelength of light you use, because we know like red waves are different than, say, purple waves. Okay. Yes, X, yeah. Another one, we can see X is proportional to 1 over D. Therefore, as distance between slits decreases, the distance between bright bands increases. And you can do that for, you know, all of the variables and just kind of compare. Oh, but I could show you here. If we rearranged it, we could go L times N if we just rearrange the formula, then you can see how x is proportional to 1 over d a little bit more. Okay. Okay, now the fun part. So